Hello friends, in this video we are going to solve a numerical in which we will calculate the tension in the string which is attached with the kite. So let's move on to a video. Let's start with problem. A dimension of a kite is given to us and weighing 7.85 Newton, weight is also given to us in Newton, which is our required unit, is maintained in air at an angle of 9 degree to horizontal. So this is the horizontal direction and kite is maintained at an angle of 9 degree like this. Say this is kite, this angle is 9 degree with horizontal. The string attached to kite makes an angle of 50 degree to horizontal. So we generally attach a string like this. So this string makes an angle of 50 degree with horizontal. If the drag and lift coefficients are, that is CD and CL, are given to us as 0.61 and 0.79, determine the wind speed. We have to calculate wind speed. If this is the inclination, then it is obvious that wind will be flowing in this direction. So we have to calculate this U. And tension in the string, we have to calculate the tension in the string. Density of air is given to us as 1.245 kg per meter cube. So given data, area of kite is 0.85 into 0.85, that is equal to 0.7225. Weight is 7.85 Newton. CD, drag coefficient 0.61, CL, lift coefficient 0.79. Density of air, that is equal to 1.245 kg per meter cube. So if these values are given to us, we can calculate drag force. Fd is equal to, for the purpose of simplicity, we will consider this is the kite, this is the string, this is the tension, this is horizontal direction, this angle as 11 degree and this angle as 50 degree. If I want to resolve some forces, so drag force is that force which is in the direction of velocity. So if this is the direction of velocity, that is u, then we have to calculate a component which is resolved in this direction. So that will be t cos of theta, t cos of 50 degree. And for lift force purpose, we have to consider one more force, that is self weight. Self weight is nothing but the, say for example, this is t sine 50 and this weight is given to us as 7.85 Newton. So drag force Fd, this drag force is nothing but only one component. So t cos theta is equal to t cos of 50. We will leave it as it is. Lift force, as per diagram, it is t sine of 50 plus weight is 7.85 Newton. We all know that coefficient of drag CD, that is equal to this drag force upon 1/2 rho u square into A, out of which we know this density, we don't know this velocity, we know this area. So by putting the values, drag force is T cos of 50 divided by 1 half into rho is 1.24 phi into u square into area is 0.7225, this much. We will have our answer as this drag coefficient is known to us as 0.61 equal to T cos of 50 degree divided by 0.45 u square. So by calculation we can calculate value of u square in terms of T. We will consider this stage because in this case we will be able to calculate value of u square in terms of T, and that value can be replaced in another equation in another equilibrium condition. So u square is equal to 2.342 times T. So we have a relation, there are two unknowns u and T, out of which we have utilized one equation, so we can calculate one unknown term in terms of second. So we have value of u square equal to 2.342 T. Similarly, coefficient of lift is lift force divided by 1 half rho u square into A. So T sine of 50 degree plus 7.85 divided by 1 half into 1.245 into u square into 0.7225, which is equal to, this equal to 0.79. So we will have value of 0.355 u square is equal to, this final term becomes 0.355, taking on the other side becomes 0.355 u square is equal to 0.766 times T plus 7.85. So I have another relation in which we can use, we can call it as equation 1, and on equation 1 and 2, 0.355 u square value is 2.3423 equal to 0.766 T plus 7.85. So we will have value of, here only one unknown, that is T, taking T on one side and other things on another side, we will have value of T that is equal to this 7.85 divided by, this is 0.1124, that is equal to 69.83 Newton. So this is the tension in string, that is equal to 69.83 Newton that we have calculated. Now the another thing remaining is velocity of flow of air is equal to, in according to equation 1 we have u square is equal to 2.342 into T, 2.342 into value of T we have calculated as 69.83. Taking square root of answer, we have value of u as 12.788 meter per second. So these are the two values that we are going to calculate. So velocity of air will be 12.788 meter per second. That's all. Thank you.